Hi everyone. Audio video volume clear? Let me know. So in the last class we were discussing data hazards. Please tell me, did you understand everything? Okay. So let's start now. Now in this lecture we will solve many questions related to data hazards, data dependency, data hazards. This concept we have seen in the last class. What is data dependency and what is data hazard? The difference between data dependency and data hazard, that also we have seen. I told you that not every dependency is a hazard. Some data dependency, they are hazard. Tell me, this data dependency, it depends on what? Like let's do some revision here. So before we move on, so let's do some revision. Okay. So you tell me, there are these are the concepts we have seen. We have seen the concept of data dependency, and there is a concept of data hazard. So you tell me, this data dependency, when you want to check for data dependency, you will only check for the code, right? Yes or no? Only code. Correct? It will only depend on the code. Okay, so just look at the code. Don't look at the pipeline. This has nothing to do with the pipeline. But when you check for the data hazard, it will depend on the code also, and also on your pipeline. What is your pipeline? Okay. And tell me one thing. How many data hazards are there? How many data dependencies are possible? How many data dependencies possible? There are three type of data dependency possible. One is RAW, read after write dependency. Another is WAW, write after write dependency. And another is WAR dependency, write after read dependency. Remember, this read after read is never a dependency. Okay, read after read dependency, this is not a dependency. Okay, remember this point. So this read after read, this is not a dependency, this is never a dependency. Okay, so this is simple point, that read after read is never a dependency, is never a dependency. Okay, hence never a hazard. Hence it is never a hazard. Okay, it is neither a dependency nor it is a hazard. For example, if you want to check, like if I give you, just tell me a simple point. If I give you read, okay, and add R1 R2, okay, and another is subtract, and in this you have, let's assume, R3 R4. Now you tell me here, is there any dependency between these two instructions? These two instructions, do they have any dependency? Is there any dependency? Do they have any dependency? Is there any dependency between these two? The answer is no. There is no dependency between these two. Okay, because remember, you can tell me a simple point. Can you switch them? Can you reorder them? Can we reorder them? These two, can we reorder? Yes or no? Can we? Yes, we can reorder. There is no problem. So can reorder. So that is the reason there is no dependency. So remember, this read after read, this is not a dependency. Okay. So this read after read is not a dependency. It's not a dependency. Is not a dependency. Okay. So tell me, in this code, how many read after read dependency are there? In this program, how many read after read dependency are there in this program? What is the number of read after read dependency? Tell me, how many read after read dependency? And the answer will be 0. Okay. There is no read after read dependency. Okay. I told you there is no read after read dependency. Then why answer is 2? Right. Okay. Why the answer is 2? So because there is no read after read dependency, this read after read is never a dependency. It is never. Okay, it is never a dependency, so it is never a hazard. So in this program, how many read after read dependency? Answer will be 0, because it is never a dependency. It is not a dependency. It is not a hazard. Okay, now we know that these three type of dependency are there in any code. In any code you have these type of dependency, these three type of dependency are there. Now One more thing we have seen, that what we call it, what is the another name for it? The another name for it, that is true dependency. The another name for it, true dependency. The another name, what is another name? That is flow dependency. Okay, these are the different names. Similarly, for this, the another name is output dependency. And for this, another name is anti-dependency. And for both of them, what we have the name? We have the name dependency. Because these dependencies, they happen because of name. I will explain, don't worry. I will explain why these are called name dependency. What is the reason these are called name dependency? These are called name dependency because they happen only because of name. Change the name, they are gone. Okay, are you getting my point? Very simple. Change the name, they are gone. So some problems are happening because of your name. Then change the name, right? Correct. Okay, in your life, if some problem is happening because of your name, then change the name. Change the name and problem is gone. So remember, these happen because of name. So change the name and these are gone. Okay, just change the name, these are gone. So these are name dependencies. You can also call them false dependencies. Okay, these are false dependencies. Now you tell me another point. A simple point I'm asking. If you have this type of pipeline, I told you this type of, what is in order pipeline? I told you in the last class, what is in order pipeline? In order pipeline means, what is the in order pipeline? In order pipeline means that, okay, that you will execute the instructions. The pipeline will execute the instructions in the program order. Okay. Yes. Okay. So in order pipeline, the name itself is telling you in order. Like if your code is like this, if your program is like this, if your program is like this, then your pipeline, then your in order pipeline, okay, then your in order pipeline will execute them in this order. In order pipeline, it will fetch, or I can say execute in this order, in the program order. Okay, in the program order. Is this clear? In the program order. Don't worry, at the end I will explain what is out of order pipeline. I will explain. Okay, at the end I will explain this point at the end. So do not worry about it. What I am saying a simple point, that if your program is like this, okay, then in order pipeline, the name itself is telling you in order pipeline. In order pipeline means execute in the program order. In this order you execute, in this order you execute. And each instruction goes through all stages. Okay, and each instruction goes through all stages. Okay, each instruction goes through all stages. Is this clear? Each instruction, every instruction will go through every stage. For example, tell me, the addition instruction, does it need the data memory access? The addition instruction, for example, if you have your classical 5-stage pipeline, in your classical 5-stage pipeline, you tell me about this instruction, the addition instruction R1, R2, R3, does it need data memory access? Does not need, right? It does not need data memory access, right? Because everything is register. So it does not need data memory access. But still, what happens? Tell me. But still, it goes through it. Okay. But still, it goes through it. You cannot skip it. It will go through it. Okay. So you have 5 stages: instruction fetch, instruction decode, and register read. Okay. Execution ALU. Then you have data memory access, and then you have a write back. Okay, so your instruction will go through all the stages. Clear? So these 2 points, are they clear to everyone? What is in order pipeline? This word clear? What is in order pipeline? In order pipeline means very simple, very like the name itself is telling you everything. The name is telling you that you execute the instructions in the program order. Okay, all the instructions you execute in the program order. If your instructions are in this order, then you execute them in this order. First you execute this, then you execute this, then you execute this, and so on. Okay. Similarly, and every instruction will go through all the stages. Okay. So this type of pipeline we call in order pipeline. This is called in order pipeline. Do you remember I told you that in order pipeline, these things do not exist? Which of them is hazard? Which of them can create can be hazard in order pipeline? In order pipeline, in order pipeline, okay, they can never be hazard, right? These two dependencies can never be hazard. They can never create any problem. These two dependencies, they can never create any problem. Do you know the proof? In the last class we have proved it. Swagtendu Debanjan, right? Do you agree? Okay, we have proved it that they can never create any problem. You will never get any problem, okay, in order pipeline. But they may create, right? Yes or no? But row hazard may exist. Row hazard may exist. Row hazard may exist. Okay, very simple. This is the point. Now, do not worry about out of order pipeline. I will explain after some time. What after? Okay, at the end I will explain what I need to explain at the end. At the end I need to explain out of order pipeline. Actually, this out of order pipeline, this is not what you think. Many students, they this idea we will see. Okay, we will just see the idea, nothing else. Okay, this idea we will see because there are some theoretical questions in the GATE exam. Okay, is that clear, Arnab? Some theoretical questions are there. So the idea we will see this out of order pipeline. Okay, so at the end we will see this out of order pipeline. In this out of order pipeline, WAW hazard is possible. I will give you the example. Okay, WAR hazard is possible. I will give you the example. And RAW hazard, of course, that is always possible. Okay, all these are possible. I will give you the example. I will also give you the example that they can be 100% eliminated. 100%, okay, eliminatable. I like eliminatable. Is that a word? Eliminatable. Is that a word? I don't know. Eliminatable, but you understood what I'm saying. Okay. 100% eliminatable. Okay. Is this clear? They are 100% eliminatable. You can eliminate them. 100% you can eliminate them. Okay. Here they are not even there. In the in order pipeline, do you need to eliminate them? If you have in order pipeline, do you need to eliminate WAW hazard, WAR hazard? Do you need to eliminate? The answer is no, because you will never get. You will never get. They don't even exist. But when they exist, then they are 100% eliminatable. Isn't it beautiful? Like these two poor people, they have no, I can say no one fears them. Okay, no one is going to fear them. These two poor people, WAW, WAR hazard. Okay, they have no terror. But this has terror. So this is the true. So that is the reason this is called true hazard, right? Or basically true dependency. Okay, anyway, you understood the point. But let's move on. So this we will see at the end. Okay, all this explanation we will see at the end. So do not worry. Now let's move on. Now let's see data hazard solution. So far we have seen that data hazards are possible. Then can you allow them? Like, for example, can you let me give you a program. Okay, consider this program that in R you are writing R1 plus R2, and then there is some instruction where something R3, R4, R5 is happening. And then let's assume there is some instruction again where what is happening here. You are using this R, you are using, okay. So let's assume now you can notice a simple point. You can notice this is a dependency. You have RAW dependency. Okay. A simple question I'm asking, is this dependency a data hazard in the 4-stage pipeline? Like, okay, let me ask you a beautiful, simple question I'm asking you. Let's assume you have so this is a data dependency. Does it have anything to do with pipeline? Does it depend on the pipeline? No, it does not depend on the pipeline. This is a row dependency. Okay. Now, between instruction I1, this is your instruction I1, instruction I3. So this is the dependency. Okay. Remember, dependency is between registers or between instructions. Dependency, is it between registers or between instructions? Like, for example, if I do this, how many, tell me how many RAW dependency? What is the RAW dependency? Number of RAW dependency, is that 2? That is only 1. Okay. Because remember, that is only 1, because the dependency, this dependency, if you notice, this is between I1, I3. This is between I1, I3. Okay. Now what I'm going to do, I'm going to give you 2 pipelines. Okay. For the same question, I will give you 2 pipelines. I will give you, let's assume that you have pipeline, 4-stage pipeline. Okay. So there are 4 stages. Let me give you the stages. The stages are like this. One is instruction fetch, another is instruction decode, another is execute, and another is write back. Okay. So let's assume there are no load. Tell me a simple point. Again, I'm asking, tell me, for these instructions like addition, subtraction, for arithmetic instruction, do you need data memory access? Look at this, look at these instructions. Look at these instructions. Do you need data memory access? No. So assume there is a pipeline, assume there is a processor in which there is only arithmetic operations, right? Can you assume? Assume there is a processor, there is a very cheap processor, okay, very, I can say, outdated processor, in which you can only do addition, subtraction, these things. It's like a calculator. Okay. So let's assume there is a calculator type of computer. There is a calculator type of processor. In this processor, only addition, subtraction, these type of simple arithmetic operations you can do. So there is no need of that stage, that data memory access stage, that is not needed, right? So that is the reason I have removed it. Okay, I have removed it. So let's assume you have a 4-stage pipeline. These are the stages. Now my question is, this I1, I3, is this a hazard? This I1, I3 is a hazard. This dependency, okay, this I1, I3 row dependency is a hazard. Is a hazard or not? Is a hazard or not? Tell me. Give me the answer. Is a hazard or not? This is a hazard or not? This I1, I3 row dependency, is this a hazard or not? In this pipeline, the pipeline details are given to you. How will you check? Do you remember how to check? A very simple point we have already seen. How to check? How to check if a data dependency, if you have a data dependency, is a hazard? Just do normal execution and see if there is any problem. Okay. So the idea is very simple. Just to do normal, like perfect execution. Can I say? Just do normal perfect execution and then see if there is any problem. Normal perfect execution. Just do the normal execution without thinking anything. Just do the normal execution and see if any problems. See if any problems. Okay. So what I'm going to do, so here, this is what I'm going to do. You have cycle C1, cycle C2, cycle so let me write like this: C1, C2, C3, C4, 5, 6, 7, 8. And these are your instructions. Your instruction I1, your instruction I2, your instruction I3. Okay, this is writing into R, right? So it will go to instruction fetch, then it will go to decode, then it will execute, then it will write back. Okay, then this instruction will go to instruction fetch, instruction decode, execute, write back. Then this instruction will go to instruction fetch, instruction decode, execute, write back. Now, there are 2 conditions possible. Do you agree that 2 situations are possible if you assume split phase, or if you don't assume split phase, right? Correct? Okay. So the case 1, let me assume the case 1. What is the case 1? The case 1 is that split phase. Split phase. Case 1 is split phase. Split phase means, what this split phase means? It means that if this is your cycle, this split phase, what it means? It means that if this is your cycle, if this is your cycle, like this is your C4, you can consider like this, that this is your cycle C4. Okay. Then in the first stage, what we do? In the split phase, what we do? Tell me, can you tell me what we do? In the split phase, what split phase means? This is split phase, what it means? It means that in the first phase, we write the register. Okay, first we write the register and then we read the register in the same cycle. Okay, write the register and then you read the register in the same cycle. In the same cycle, you can do these two. So I told you something beautiful, like whenever you are having this diagram, then how to denote this split phase? You can denote like this, correct? That your data is available here. Okay, you can denote like this. This is just like our trick. This is our secret. This is Go class's secret. Okay, so you can assume that your data is available here. So at this point of time, your data R is available, correct? Your data R is available, right? This R. So I can say R correct value is available. This correct value R is available here. Okay, if this is available here, but where do we need? So we can read it, right? We can read the correct value here in the second, in the second half of cycle 4. Like for example, here this is available. Here your value is available. Okay, at this point your value is available. So we can read it, right? In the decode phase, we can read it, correct? Do you agree? In the decode phase, we can read it. Okay, so there is no hazard. There is no hazard. Okay, because you need this value. Okay, you can read this here. So it's like you can read this here. There is no problem. There is no problem. You can read it here. Okay, so basically we are reading the correct value. So we are reading correct value. So is there any hazard? Is this hazard? So this is not a hazard. So in this case, if you are assuming this, then there is no hazard. In this case, I can say that this will be no hazard, no RAW hazard. In this case, there is no RAW hazard. Agree? Okay, very simple. There is no RAW hazard. But what about in this case? If you assume this, if your case 2 is this, that write happens at in the second half. If this is your cycle, if I assume this is your cycle, okay, then write register happens here. Here you write into register and here you read the register. So you read the register first, then you write into register. Now in this situation, you can see that here your correct value R will be available. Okay, at this point, your correct value of R will be available. So you tell me, can you read it like at the end, but you are reading here? Yes or no? Like this is time travel, correct? This is time travel. It is time travel. Can you do time travel? Can you do time travel? Like the value will be available here. You want it here. That is time travel, right? Agree? That your value, correct value will be available here. At this point, correct value will be available, but you want it here. That is time travel. Time travel is not possible. Okay, so you can notice this is your time travel. You can clearly see this is time travel, which is never possible. Never. This is never possible. You can never do time travel. This is time travel because, why this is time travel? Because the value, correct value will be available here. You want it here. So that is time travel. Okay, this time travel is never possible. That is the reason this is hazard. Okay, so you have row hazard here. This dependency will be a row hazard in this situation. Okay, so this is your, I can say this is the hazard. Okay, clear? Understood? Let me know. Okay, so you tell me, you know that there is hazard. Can you allow the hazard? Can you allow the hazard? Like you know there is a hazard. Can you allow the hazard? In the system, can you allow this type of hazard? Can you allow? Because what is happening here? When you are reading the wrong value, right? Can I say that at this point of time, wrong value we are reading? At this point of time, you can notice we are reading wrong value. Correct? The reading wrong value of R. We are reading here at this point of time, we are reading wrong value. We are reading, remember. Okay, wrong value we are reading. So that is not allowed. You like you cannot allow reading wrong value. So we need to handle hazards. So there is a need to handle hazards, right? There is a need to handle hazards, correct? We need to correct the execution. There is a need to handle hazards. Handle hazards so that we get correct execution. So that we get correct execution. Okay, so there is a need to handle hazards. Remember, we have a need to handle hazards. So because we want correct execution, we cannot compromise with the correct execution. Now, what are the ways to handle hazards? So let me give you total. There are, for data hazards, there are 3 ways. For data hazards, whenever you have data hazards, there are 3 ways to handle it. Okay, actually, there are 2 ways to handle it. Okay, so let me tell you, very beautiful concept is coming. Just understand this. Very simple concept is coming, that you want to handling data hazards. You want to handle the data hazards. Okay, then there are 2 ways. What are the 2 ways? Either you delay or you correct the wrong things. Okay, like either you don't do the wrong things or you correct what you have done wrong. Okay, see, something interesting will come, don't worry. Let me tell you, the first way is don't do wrong. Don't do any wrong. Okay, right? Yes or no? Correct. Don't do any wrong. Just don't do any wrong in the first place. Don't do any wrong in the first place. I can say, don't do any wrong in the first place. Don't do any wrong in the first place. Okay, or basically don't read any wrong value in the first place. Okay, what it means, let me explain what it means. It simply means that don't read wrong value. It simply means don't read wrong value at all. Don't read wrong value at all. Okay, don't worry, it will be clear. This point will be clear. I know that it is not clear right now, but it will be clear. So do not worry. I am just saying that there are 2 ways to handle your sins. Like it's like you are making some mistake. There are 2 ways. What are the 2 ways? Either you don't make a mistake, or what is the another way? Tell me. Either you don't make a mistake. Don't make a mistake. That is one way. What is another way? What is another way? Another way is, if you have made the mistake, then rectify it. Very good, very good, very good. Okay, made the mistake, then rectify the mistake. Rectify your mistake. So there are only 2 ways. Isn't it like very, I can say, very intuitive that there are 2 ways. Either you don't make a mistake, or if you have made the mistake, there is another way, that is rectify your mistake. Rectify your mistake means, what it means, let me tell you. It means that fix the wrong values that you have read. Fix the wrong values that you have read. Means fix means correct. Fix means correct. Like correct the wrong values that you have read. Okay, correct the wrong values that you have read. Error correction. Very good, very good. Okay, so there are 2 ways. Either you don't make a mistake, or if you have made a mistake. So there are 2 ways. Now let me tell you, this first way, this is, in this what we do, we stall. This is the first way. In this first way, we stall. This is the way of, I can say, stall way. Okay, you can understand like this. Okay, the first way is stall way. Stall means delay. Stall means bubble. Okay, so this is the stall way. Yes, I will come to that point. Don't worry. Debanson, don't worry. I will come to that point. So the first way is stall way. Stall means delay way. Okay, it's like a gay. Mahi way. Okay, so anyway, the point is that this is your delay way. This is the first way. Now, what is the next? The next is the second way. What is the second way? That is called operand forwarding. That is called forwarding way. That is called forwarding solution. Okay, so there are 2 solutions. One solution is stall solution, and the another solution is forwarding solution. Okay, let me explain both of them. So basically, there are handling data hazards. There are 2 solutions. Please understand, there are 2 solutions. One is stall solution. Stall means delay, or you can say bubble, Okay, so this is stall solution. There is one solution that is stall solution, and there is another solution that is forwarding solution. Okay, there is two ways. Now, one by one, I will explain both of them. There are two solutions. Intuitively, you understand. Intuitively, okay, in your mind, just imagine it. Like here, basically, you are delaying, so you are not committing the mistake. You will not commit the mistake. You will never do the mistake. And here, what you will do? Here, you will fix your mistake. The mistake you have done, but you want to fix it. Okay, clear? Okay, so there are two ways. Now let me tell you. Now let's see the first way, that is stall way. What is the first way? That is stall way. So you can notice detecting data hazards. There are two solutions. You want to handle them. There are two solutions. One is stall. Another is fix what you have done. Fix the values that you have. Fix your mistake. Now let me explain the stall way, the stall solution. The first solution I will explain, that is stall solution. Okay, this stall solution. What this stall solution means? It is very simple. Okay, it is very intuitive. This stall solution I will explain, but before that, let me tell you that this stall solution, either you can put this responsibility on hardware. Okay, are you getting my point? Either you can put this solution responsibility, this stall solution responsibility, either you can put on the hardware or you can put on the software. Both of them we will explain. I will explain. Either you can put this responsibility on the hardware or you can put on the software. By software, I mean compiler. So either you can put this responsibility on the hardware. By hardware, I mean your decoding phase. Okay, so you can notice that either this responsibility you can put on the software. Software means compiler, or you can put this responsibility of not making mistake. What is this solution? This solution is what? This solution is not making mistake, right? Correct? This not making mistake solution. Not making mistake solution. So for this not making mistake solution, either you can do this or you can do this. Either you can put the responsibility of not making mistake on hardware, or you can put the responsibility of not making mistake on software. This solution is also called NOP solution, NOP instruction solution, inserting NOP instruction. Don't worry, I will explain. Like right now, I am just giving you the overview. I know you are not understanding, but don't worry. With example, everything will connect. Okay, inserting NOP instruction solution. Maybe this type of question you have seen in the Go classes test series, right? Inserting NOP instruction, inserting NOP instruction. Okay, so this solution I will discuss finally now. Okay, so, and this is actually very intuitive. This is just very intuitive. So actually solution is same, but that is implemented in two ways. Do you agree? The solution is same. We have the same solution, but it is implemented in two ways. Either you can put the responsibility on the hardware or you can put the responsibility on the software. So the solution is one, only one solution you have, that is stall solution, but the responsibility either you can put on hardware or software. So let me show you how you can put the responsibility on the hardware. Okay, is this clear? The stall solution. So let me show you. So let's take one program. Let's take. Okay, so you can take this program that you have instruction I, and this instruction I is something like this. In the register R, you are putting something. Okay, and then instruction I2 is something like a completely independent instruction. So let's assume that is completely independent instruction. Okay, just assume that it is completely independent. Like this instruction is completely independent. It is purely independent instruction. Independent. Okay. And there is I3. I3 is what? In I3, you are reading R. Okay, something like this. So, understood? So you have three instructions. Let's assume you have this pipeline. Your classical 5-stage pipeline you have. Okay. Which pipeline you have? Classical 5-stage pipeline. Okay. So this is what you have. Classical 5-stage pipeline you have. And let's assume that you have split phase you are using. Okay. And let's just assume that split phase used. Assume split phase used. Assume this is what you assume. Assume split phase is used. Okay. Now what you do, you now just explain. Now let me explain what I will do. I will explain. First, I will explain the here hazard will come. You can check it out. Can you check it out? Can you check it out? Hazard will come. First of all, can you check it out that hazard will come? This hazard is going to come. Can you just check it out? Okay, definitely. First of all, you can easily see that hazard will come. Okay, so let me explain that hazard will come. Actually, here RAW hazard is there. Before handling the hazard, you must be sure that hazard is there, right? So before handling the hazard, first you check, is there hazard? Okay, yes, there is hazard. You have row hazard because you can see cycle C1, 2, 3, 4, 5, 6, 7, 8. And then you have instruction I1, and then you have instruction I2, instruction I3. Now you can notice that instruction I1 is going to instruction fetch, then it will decode and read the registers, then it will go to execution stage, it will use the ALU, then it will access the data memory, and then it will write back to the register. Okay, the same situation will happen here. Finally, this I3 will go to instruction fetch, instruction decode, execution phase, and then memory access phase and write back phase. Now you can easily notice that split phase is used. You are using the split phase, but this value is needed here, right? You are using the split phase. But still the value is used here. So this is time travel, right? This is your row hazard. Because this is time travel, right? You can consider this as time travel. You are traveling into time. Like the value will be available in the cycle C5. The correct value will be available in the cycle C5, but you need it in the cycle C4. So that is your RAW hazard. Now we want to handle this hazard. Okay. So what I ask you, so there is there exists RAW hazard. You have RAW hazard here. This RAW hazard you have from which instruction to which instruction, between which instruction to which instruction, I1 to I3. Okay. I1 to I3, there is a one RAW hazard you have. Okay, now handle it. Okay, now what you do? So just basically you need to, you can't allow the hazard. Okay, so just basically using software, using hardware solution, using hardware install solution. Okay, using hardware install solution. Okay, basically I can say that handle the hazard for correct execution, so that you can get the correct execution. Handle this hazard so that you can get the correct execution. Okay, so now let me tell you, actually this is very intuitive concept. This hardware install solution, this is very intuitive concept. Let me tell you. So what is this hardware install solution? So let me tell you, this hardware, like this install solution by hardware, this install solution, this is very intuitive. Okay, by hardware. So what the hardware will do? Very simple. It will just delay. Okay, the solution is very simple. Just install or delay. Just install or delay. But okay, but read correct value only. But read correct value only. Correct value only. The name itself is telling you. The name itself is telling you that just install. Just install, but read the correct value only. So what you will do? Let me tell you. This is what you are going to do. Okay, this is what you are going to do. In the cycle C1, there is cycle C1, C2, then C3, then okay, then 3, then 4, 5, 6, 7, 8, and so on 9. Now, okay, now instruction I1, this will go to instruction fetch, it will decode, it will go to execution, it will go to memory access, it will write back. This instruction I2 is completely independent, so you don't have to worry about it. It will go to instruction fetch, instruction decode, execute, MA, WB. Okay, now finally this instruction 3, what it will go? So in this cycle, it will go to instruction fetch. You can fetch it because in this cycle, you can easily fetch it in this cycle. Okay, you can fetch the instruction I3, then it will go to instruction decode. Now, where the value will be available? The value will be available here, right? Correct. This is where correct value is available, right? Yes or no? Here you have correct R value. The correct R value is available here. So tell me, can you go to execution phase? Can can this instruction I3 go to execution phase because it is reading the wrong value here, right? Yes or no? In this ID stage, you are reading the wrong value. Can you go to the execution phase? You cannot go to the execution phase, right? Because here you are reading wrong value. Here you are reading wrong R. So what you need to do? You need to wait here, right? Correct? You need to wait here. You are reading wrong R. So wait. So wait. That's it. That's it. So wait. Wait. Okay. Just wait. So in the ID stage, you wait. So in the next cycle also, in the ID stage, you will be. Why I'm putting this underline? What it means? It means bubble. This underline I am putting so that it tells you that it is bubble. Why this is bubble? Because here execution phase is idle. Your execution phase is idle in cycle C5. In the cycle C5, execution phase is idle. Okay. So this I am putting, this line I am putting for bubble because you are waiting. So you are waiting in the ID stage. You are waiting. Now you tell me in the cycle C5, can you read? In the cycle C5, can you read the correct value? Yes, you can read the correct value because split phase we are using. Yes or no? We are using the split phase. You can notice the split phase you are using. So you can read the correct value because you are reading the correct value. So no problem. So go to execution stage, then go to MA stage, then go to WB stage. That's it. Khatam. Finish. So this is your solution. Did you notice this is very intuitive solution that just delay, just wait. Right? Yes or no? This is your solution. This is your, I can say, stall solution. This is the stall solution. Just wait. This is your wait solution. Stall solution, wait solution. Understood? Is this understood? Let me know. Can you notice now? Because we are waiting, we are getting the correct execution. Because we are waiting, because we are delaying our read. We don't want to read the correct wrong value. We don't want to make any mistake. We will wait, no problem. We will stall, no problem. Can you notice? We are getting the correct execution. Can you notice? We are getting the correct execution. Yes, we are getting the correct execution. This is what we want. That's it. This is your hardware solution. Understood? Okay. Now the same question, if you don't have any split phase, if you don't have any split phase, in the same question, if we do not have any split phase, now what? Now what? For the same question, you have classical 5-stage pipeline and assume register write happens at the end of the happens in the second phase of cycle. Okay. Now you give me the same, for the same example, you give me the stall solution. So there is hazard here. So again, there is a RAW hazard. Okay. Now, because of this RAW hazard, so there will be one RAW hazard, but because of this one RAW hazard, now you will see there will be two bubbles. You will see that there will be two bubbles. There will be one RAW hazard in this. You have one RAW hazard. Okay. But there will be two stalls. So just make the stall solution. Stall solution. This stall solution you apply. When you apply the stall solution, you will see that there will be two stalls. You will get two stalls. Can you try this? Can you try this? Let me know. So just try this one. Okay. For the same program, this is your program. Just do it. You will see that there is only one RAW hazard. Okay. Use the stall solution. Don't make any mistake. Stall solution means don't make any mistake. Okay. We will wait. No problem. We will wait, but we will get two stalls. Okay. So let me solve it. C1, then you have C1, then you have 2, then you have 3, then you have 4, 5, 6, 7, 8, 9, and so on. Then you have instruction I1, which will go to instruction fetch, instruction decode, execute, MA, and then you have WB. Instruction I2 is completely independent. Instruction fetch, instruction decode, execute, data memory read, and then write back. And instruction 3 is instruction fetch. You are fetching it. There is no problem. You can fetch it. In this cycle, you can fetch it. Okay. The value will be available here. Agree? Here the correct value, correct R value will be available here. Here the correct R value is going to be available. You will write the correct R value here. Now you are in the ID stage. What you are doing, tell me. In the ID stage, you are reading the wrong value. Reading wrong value of R. So what we will do, tell me. Okay, because the correct value will be available here. The correct value is going to be available here. So what we will do, we will wait. So wait. So wait. So what you do, you wait in the ID stage. In the ID stage, you wait. So there is a bubble. So there is a stall. Okay, there is a bubble. Now you tell me, okay, you just tell me, can I read the value in the cycle 5? Can I read the value in cycle 5? Can I read the correct value in cycle 5? No, I cannot, because you can notice here the value will be available. I want the value here. I want the value here. Here the value will be available. I want the value here. I cannot do that. So what I need to do, tell me. Again, I will wait. Again, I will wait. Okay. So there is another stall. Then finally, I can go to execute. Then I can go to MA. Then I can go to write back. That's it. So there are two stalls. Okay. Very simple. See, Arnab, second stall, because tell me in the cycle 5, can I3 read the correct value? In the cycle 5, can I3 read the correct value? Array, very simple. See, this is the given in the question that read happens in the first half. Array, because read happens in the first half. In the question it is given. In the question it is given that register write will happen in the second half, read will happen in the first half. Basically, if this is your cycle, consider this is your cycle C5. This is your cycle C5. Okay, let's zoom it. Zoom. This is your zoomed version of cycle C5. Zoom it. In the cycle C5, here the write will happen. Okay, here you will write. Here you will write the correct value of R. So the correct value of R will be available in the second phase. But you are reading here. Okay, are you getting my point? See, the ID stage will read here. The ID stage will read here. ID stage is reading here because ID stage has the work of reading. ID stage needs to read. So this will read the read here. But the you can notice that this I1 writes here. Okay, I1 write back stage. And this is your I3. So now is this understood? Okay, so you can notice that basically we are writing here like the correct value will be available here, but you want it here. Is this understood? Understood? Tell me. Like the value will be available here. The correct value will be available here, but you want it here. Can you do that? Like the value will be available here, but you want it here. That is time travel. We cannot do time travel. Clear? Let me know. Arnab, Sudeep, let me know. Is this understood? So you can notice that you cannot read the instruction I3. Please understand that instruction I3 cannot read in the cycle C5, right? Yes or no? In the cycle C5, we cannot read the correct value. So that is the reason. We need to wait so that we can read the correct value. Now, in the cycle C6, we can read the correct value. In the cycle C6, we can read the correct value. Okay, clear? So very simple. Debanjan, the doubt that you are asking, just wait and let me cover it. I will take many questions. Okay, at the end you ask. I know that the doubt that you are asking because you have seen somewhere else. Okay, right? Yes or no? Something you have seen somewhere else, that is the reason you are asking your doubt. But just wait. Okay, let me cover the gate questions, let me cover the entire part, then we will discuss. You can ask, you can speak also. Okay, so understood. How many of you understood this, that in the cycle C5 I3 cannot read the correct value, so I3 will read the correct value in the cycle C6. In the cycle C6 it will read the correct value. So there will be two stalls because of one hazard. Because of one RAW hazard, you are getting two stalls. So the solution, is this solution understood? Can I say that you understood this stall solution? Did you understand? Did you understand this stall solution? Understood? Let me know. Did you understand this stall solution? Stall solution, very simple. This solution simply is, this is very intuitive solution. Let me tell you, this is very intuitive solution. It is very intuitive solution. Just wait for the correct value. What this solution says? This solution says that just wait for correct value. Wait for correct value, but don't read the wrong value. Just wait for correct value. Always read the correct value. Understood? Always read correct value. Remember, in the ID stage we are reading. In which stage we are reading the register? In which stage? Which stage will read the register? ID stage. So that is the reason. Okay. Always read the correct value. This is your stall solution. Now. The same stall solution. The same stall solution. Actually, the solution that we have seen. Okay. You might be thinking, right, sir, like, why this is called hardware solution? Anyone want to tell me why this is called hardware solution? This is called hardware solution because we are putting the responsibility on the ID stage. It is the responsibility of the ID stage that you detect the hazard, and then you wait. Are you getting my point? It is the responsibility of this stage. It is the responsibility of this hardware that you detect. First you detect the hazard and then you wait, then you stall. So on whose shoulder we are putting the responsibility of detection and stalling? On whose shoulder this responsibility we have put? Tell me. We have put the responsibility on the shoulder of decoder, on this stage, the decoding stage. Okay, on the hardware we have put this responsibility. Now there is a very nice doubt Swagtendu is asking, how it is implemented. See, there are some algorithms, Swagtendu. There is a Thomas Sule algorithm, and some algorithms are there, and those are not at all required for the GATE exam. Okay, there is an algorithm, Thomas Sule algorithm is there, and that is really like complicated algorithm. Also, that is not required for the GATE exam. Okay, but the point is, what you have seen on your screen, what I told you, that can be implemented, and that implementing algorithm is Tomasulo. Is this clear, Swagtendu? Basically, it's like what we have done that can be implemented, okay, using that algorithm. But we will not go into that algorithm. That is not at all required for the GATE exam. There is not a single GATE question where you need that algorithm. Okay, so if it was needed, I would have taught. But anyway, that is not needed. But the point is, it can be implemented. Okay, it is the responsibility of this decoding stage. Okay, it's like this decoding stage must detect the hazard and then it must stall. Okay, detection and stall. This responsibility we are putting on the decoding stage. Understood? This solution, this hardware solution, you understood, very intuitive. Now the same thing, what you do? Now the same thing, if I put the same responsibility, this stall solution responsibility, if I put basically the stall solution hardware version, we have seen the hardware version. Okay, This hardware version we have seen that your decoding phase has this responsibility. Now let's see this install solution software version. Means software implementation, or I can say software solution. So what is software solutions? By software, I want to say compiler. So what your compiler does, see, okay, now your hardware will not do, but what your compiler will do, your compiler should be very smart. It should be very smart. And your compiler, what it does, when it sees this instruction, like you are writing, you are like, you don't care all these about all these things. You are just writing your program. Okay, there is I2 and there is I3. You are writing your program. Okay, is this understood? This is your program. This is your code. Now, the compiler should be very smart. The compiler knows that there is a dependency. Okay, the compiler knows that there is a dependency, and the compiler knows that you need the distance of 2. Basically, the compiler has the information of the platform. Okay, the compiler has the information which pipeline is used. Okay, so basically, in that situation, what your compiler will do, it will insert 2 NOP instructions. What it will do, it will insert 2 NOP instructions. So what your compiler will do, this is what your compiler will do. Your compiler does this. I1, then I2, there is no problem. Okay, I2, there is no problem. Then it inserts 2 NOP instructions. NOP means nothing, just do nothing. NOP instruction means just do nothing. Just do nothing. Do nothing instructions. It will insert 2 NOP instructions. Why it is inserting 2 NOP instructions? Anyone? Why it is inserting 2 NOP? Why not 1 NOP? Why inserting 2 NOP? Because there are 2 installs. Yes or no? Because we were getting 2 installs. Remember, both are same. The software solution and the hardware solution, the both are same. Okay, in the hardware solution, the same responsibility you are putting on the hardware. In the software solution, the same responsibility you are putting on the compiler. So your compiler must insert 2 NOP instruction so that you can get the correct execution. Why we are inserting 2 NOP instruction? Because we were getting 2 installs. If we are getting 1 install, then we will insert only 1 NOP instruction. Understood? Please tell me. So in the exam or in any question, if I ask you how many NOP instructions to insert, then how will you do that? How will you check that? If I ask you how many NOP instructions we need to insert, then what you will do? Just do the hardware solution. That is easier. Yes or no? Just do the hardware solution. Do the intuitive solution, very intuitive solution you do. Just always read the correct value. Just do the execution using the hardware solution. And that will tell you how many NOP instruction to insert. Understood? Please tell me. Don't worry, I will take question. There are questions in the Go Classes test series also. Some standard questions I have already put in the Go Classes test series from the standard resources. But very simple. This is extremely simple that we are putting 2 NOP instruction because we were getting 2 installs. Why? Because we were getting 2 installs. Okay. This is your NOP instruction solution. So how many NOP instruction you need to insert? This is your NOP solution, I can say. Install solution, you are putting the responsibility on the compiler. That's it. So can we move on now? One more solution is there. One final solution I want to tell you, and that is interesting. That is forwarding solution. The second solution that I want to tell you, that is forwarding solution. What forwarding solution? This is interesting, and this is most, I can say, misconception. In this solution, there are many misconceptions. So please understand everything. Okay, very clearly I will explain what is this forwarding solution. This is like this. Let me assume that you have 2 instructions. Let me give you instruction I1, and that is you are writing into R, and instruction I2 where you are reading something. Okay, so there is a dependency. So there is a RAW dependency. And this will create a hazard. You know that this will create a hazard in the MIPS pipeline. Okay, so this will create a hazard. This you already know that it will create a hazard in MIPS pipeline. MIPS, what is MIPS pipeline? In the last class, I told you that is your classical 5-stage pipeline. Okay, so in the classical 5-stage pipeline, this will create a problem. Okay, now something beautiful in this forwarding solution, you just assume that, see, C1, 2, 3, 4, 5, 6, 7. Okay, instruction I1, instruction I2. It is going to instruction fetch, instruction decode, execute, then okay, access, and then write back. And what this is doing, this I2, it is going to instruction fetch, instruction decode. Okay, see something beautiful. Tell me, the value in the register R, the correct value will be available where? In which cycle the correct value will be available in R? In the register R, in the register, I am asking, in the register R, when the correct value will be available, in which cycle it will be available? At the end of the cycle 5, yes or no? At the end of the cycle 5, because here you will write into R. This is the write back stage. In this stage, your R will be updated. But see, R will be updated in the cycle 5, I agree. But the value which you will put in R, that is available where? The value that you will finally put in R, that is available where? That is already available in the execution stage. In the execution stage, that is already available. No, see, you are doing some calculation right here. See, you are doing some calculation, and this value you are putting here. Some calculation you are doing, that value you are putting in R. Basically, this value, look at this value V. Let me call it V. Where this value V is available. Where this value V is available. This value, do you agree that this is available here? Here that V is available. That V is actually available here. Okay. And so what we can do after the execution stage, this is your execution stage. What do we have after that? What we have? Finally, now you will understand the logic of latches. The logic of latches you will understand finally. This is your instruction decode stage. Now you can notice that. So this value, this instruction I1 in the cycle 3, it will put the value here. Agree? At the end of the cycle 3, at the end of the cycle 3, at the end, remember, at the end of the cycle 3, the value is available where? So tell me, value is available where? In the buffer of execution stage. In this buffer, in the buffer of execution stage, correct? Agree? At the end of the cycle, this is very normal, very simple concept, that you know that this calculation will happen. Okay, in the execution stage, this calculation will happen. At the end, this value will be available. This V value will be available. Okay, this value V will be available. So this value will be here. Okay, so what it means? It means we are reading the wrong value. It means we read the wrong value. Do you agree that it means we read the wrong value? We read wrong value, correct? It means I too read the wrong value, correct? But what we can do, mistake has happened. Okay, mistake. I too has done the mistake. So what we will do? You have read the wrong value. But what we can do, from this execution, from this buffer directly to this execution stage, we just supply the value. Okay, for this value, we directly supply to the execution stage. This value we directly supply to the execution stage. See, we are reading the wrong value, but I will correct my mistake here. I am fixing my mistake. Do you remember? This is what I told you. Forwarding solution means rectify your mistakes. Understood? Please tell me, did you understand this? What is happening here? Many students have misconception in this forwarding solution. They don't really understand forwarding solution. They just like, okay, some vague idea. Okay, yeah, forwarding will happen. Arey, how it will happen? Ultimately, everything should happen on the hardware. Yes or no? Everything, whatever you do, everything must happen on the hardware. Whatever you do, you can never do time travel. Okay, all these things you should take care. This forwarding solution, did you understand now? That what I'm saying, I'm very simple. Okay, just understand. I'm again telling you, just listen to this line. At the end of the cycle 3, and at the end of the cycle 3, the execution stage buffer, that register will have the value V. This value V, I2 needs. So what we will do, this I2 is reading the wrong value in cycle 3. Okay, I2, this instruction I2, it is reading the wrong value in the cycle 3. So what we will do, we will rectify that mistake. The correct value from the execution buffer, we will transfer to the execution stage of I2. Understood? So this connection we will make, that from this buffer, the value will directly go to the execution stage. So remember, you are reading the wrong value. Yes, you are reading the wrong value, but you are fixing it. But you are fixing the wrong value. You are fixing the wrong value. Understood it? Did you understand this? Did you understand this data path? This data path, did you understand this data path? Okay, so very interesting solution, right? So we will send this value to the execution phase. Now there is no problem. So you remember, even though I2 is reading the wrong value here, this I2, this is reading the wrong value here, but the calculation is happening on the correct value. This is interesting. This I2 is reading the wrong value, but the calculation will happen on the correct value. So ultimately, so there is no problem. So it can go to MA, then WB. That's it. This is your forwarding solution. Okay, so this is your forwarding solution. So what is forwarding here? This is the forwarding, that this is your execution stage. This is your execution buffer. This is your decode buffer. Or maybe I can use the same color. So this is your execution buffer, and this is your decode phase, and this is your decode buffer, and this is your MA phase, this is your MA buffer. Okay, so you can notice that what we are doing finally, we are just doing this. This is your ID, this is your MA, and what we are doing, this value we are transferring directly to the execution stage. This is the data path. This data path you understand. This is called forwarding data path. Actually, the name is forwarding, but the data path is like backward. Okay, the name is forwarding. It's basically, the name is forwarding because you are forwarding the data. Okay, you don't have to wait till the end. See, you don't have to wait till here. You can take the data from here. So that is the reason this is called forwarding. But this data path, did you understand? This is your forwarding data path. So this forwarding, this is from where to where, from which stage to which stage? This forwarding, this is from which stage to which stage? From which stage to which stage? This is from execution stage to execution stage. Understood? This is from execution stage to execution stage. From the execution stage, you are sending to execution stage. From the execution buffer to execution stage. So this forwarding is from execution stage to execution stage. Understood? Please tell me. Understood? Let me know. This idea, did you understand? Okay. We will take a lot of questions. Do not worry. Okay. But I hope you understood that what is forwarding. Forwarding basically, let me tell you a simple idea about forwarding. Forwarding basically, if the value is available somewhere, if the value is available somewhere, if the value is available anywhere, if the value is available somewhere, if the value is available somewhere already, okay, the value is available somewhere already, then bypass it, then use it, bypass it, or forward it, or forward it to the place where it is used, where it is needed, where it is needed. Understood? Okay. Very simple, right? This is what we have done, right? That if the value is available somewhere, already the value is available somewhere, then you bypass it or you forward it to the place where it is needed. That's it. This is your forwarding. Let me tell you, for the data hazard, two solutions we have seen. What are those? Two solutions we have seen. We have seen the solution of stall. We have seen the solution of stall solution. And what is another? What is another? That is forwarding solution. One is stall solution, another is forwarding solution. Let me tell you, these are not exclusive. Sometimes both are used. Sometimes both are used. It's not like they are exclusive. Sometimes both are used. I will give you one example. Sometimes both will be used. Okay, so let's take this example. Consider this question on your screen. Okay, consider this and tell me the answer. See, consider this one. See, very simple. You have pipeline is given to you. This is the pipeline: fetch, read, ALU, memory, and then register read. Okay, this is your pipeline, and these are your instructions. You need to tell me, for this, do we stall or do we forward? For this, do we stall or do we forward? Let's see. Try this. Are you getting my point? What I'm saying? I am saying, for this, do we stall or do we forward? What should we do? For this, do we stall or do we forward? What should we do? Sometimes both need to be done. Sometimes one of them is enough. Let's see if you can solve this. Okay, let me solve it. Okay. The next question, that gate question, you can solve. Let me solve it. See, very simple. So let's see these two instructions: multiply and load word. So you have these two instructions: multiply. In the multiply, what you are doing, in R1 you are putting something. In the load word instruction, what you are doing, you are using R1, and in R1 you are putting something. Like in R1 you are putting, but you are using R1. Okay, something you are doing with R1. So something like something you are doing from R1. So you are reading R1 basically. So this is your RAW dependency. This is your RAW hazard also. You already know this. Okay. Now, so you tell me what we need to do for this one. What we need to do for this one? Actually, you don't need to you don't need to write the whole thing. You just need to write where this is a reading and where this is writing. You need to focus there. Okay. So you just need to focus where it is writing. So when this I1, when this multiplication, look at this multiplication. When this multiplication is in the execution phase, where is this LW? Where is this LW? Like, tell me, when this is in the execution phase, where is LW? That is in the decode phase, instruction decode phase. Okay. Now you tell me, LW needs R1, right? So is LW where the this, whatever this calculation you are doing, like R2 plus R3, whatever this calculation you are doing, where this result will be available, where this value will be, this value, where it will be, when it will be available, let's call it V. So it will be available here. Very good. Okay. Here you can notice this V is available. Where it is available? V available in execution buffer. In execution stage buffer, it is available. This is your execution stage. In the execution stage buffer, this value V is available. Okay, at this point. So in the next cycle, what will happen? You can notice that LW is reading wrong value. Wrong value of R1. It is reading the wrong value of R1, but there is no problem. Why there is no problem? You can do the operand forwarding. You can forward. Okay. The value that you have, that value you can forward to the execution stage. Right. This value you can directly send to the execution stage. Correct or not? You are reading the wrong value, but you are basically fixing. You are fixing the R1. Okay, you are fixing the R1. This R1 value that you are reading, you are fixing it. Okay, so because you know that the value is available here, is this time travel? Is this time travel? Am I time traveling? No, I am not time traveling because the value is available here. I am forwarding it directly to the execution stage of LW. Okay, so this is the data path. You can notice. So tell me here, stall is not needed, right? Do you agree there is no stall? We have no stall. So here answer will be what? For this question, answer will be what? That here there is no stall needed. Forwarding is enough. Stall is not needed. Forwarding will take care. Forwarding is enough. Okay. Now let's see the second one. What is the second one? The second one is this. LW comma add. Okay. Now focus. LW comma add. So now you have to focus on this. LW. In R1, you are putting something. Okay. In R1, you are putting something, some value you are putting, something you are putting. And then you have this add. Okay. Then you have this add. In R1, again, you are putting some R1 plus R1, something you are putting. So again, there is a RAW dependency. Actually, this also will be RAW hazard. You already know this. This you already know that it will be RAW hazard. It is going to be RAW hazard. Okay. So tell me, can operand forwarding give us a perfect solution? Using operand forwarding, can we get a perfect solution? Or do we also need to stall? Like even after using the operand forwarding, even if you use operand forwarding, then also it is possible that you may need to stall. It is possible. And this example will tell you that. Because remember, very simple. Let me answer it. It's C1, then you have cycle 2, cycle 3, cycle 4, cycle 5, cycle 6, cycle 7, and so on. This is your instruction LW. It is in the instruction fetch, then it will go to instruction decode, then it will go to execution, then MA, and then WB. Okay. This is your addition instruction. This addition instruction will fetch here, will decode here. Okay. A very beautiful thing I'm asking. Can this operand forwarding work? Can you do this forwarding? Can you do this forwarding? Can you do this forwarding? No. Why? Sudeep, what is the reason? We cannot do this forwarding. Because the value is not even available here. Please understand a simple point. Because this V, let's call it V, when it will be available. Remember this is, okay, from the memory you need to read this. From the memory, it's like from the main memory you need to read this. So it's like this value will be available here. When you access the memory, here it will be available. Here we will be available first. Okay, here. Understand, please understand. In the execution phase, what the load word is doing, what this LW is doing in the execution phase. In the execution phase, LW instruction, what it is doing? It is calculating the address. Yes or no? It is calculating the address. Address calculation is happening. In the MA phase, in the data memory access phase, it will finally bring the correct value. So finally, your correct value, this value V will be available here. You don't even have V here. So there is no opportunity. You have to delay. You have to delay. Correct? You have to wait. There is no other choice. You have no other choice. You have to wait. You cannot do anything. But now you can do something. Now value V is available, right? At here, like in the MA, this is your MA phase. And here the value is available. In this buffer, the value is available. This is your execution phase. So tell me from where, what should be the data path? If I want to do this, then what should be the data path? The data path should be what? The data path should be from here, the value will directly go to the execution stage. This will be your data path. Okay. KS is asking, sir, in third stage, doing M plus R1. No, this M means in the third stage, you are doing something, maybe 0 plus R1 or 2 plus R1, something you are doing. See, something you are doing, like maybe 2 plus R1 you are doing. Is this clear? KS? Some address calculation you are doing. And this M simply means that memory. This M means memory. And this is the address. This is the address. On this address, go to the memory. In the memory, go to this address and bring the value V. Is this understood, KS? This data path, how many of you understood this data path? That the value V will be available here. Okay, the value V will be available here. But where we need in the execution stage. Are you enjoying this topic? Like, I am really finding it very interesting. Everything is very intuitive, very logical. Very logical. You don't have to by heart anything. Did I tell you anything which you need to by heart? Like everything I'm just explaining very intuitively, very logically, we are understanding everything. This is how things should happen. Okay. Logically, if you think about it, logically, this is how things should happen. You cannot do time travel. You cannot do wrong execution. Is this clear? Please tell me. Very logically. One more thing I want to tell you. Once you understand this pipeline logically, will you ever forget it? Like, you can never forget it, because ultimately this is just logic. This is just pure logic. There is no formula. There is no formula. I did not give you any formula which you need to by heart, which you need to remember. Like, just remember this formula. I did not tell you. Just remember these facts. Fact 1, fact 2, fact 3. Just remember these. I did not tell you. Everything we are proving, everything we are seeing very intuitively, very logically. All these concepts are very easy. Anyway, let's come back to this point. Did you understand this? This data part, did you understand that? Here the value is available. The value V is available here. So we can forward this to the execution stage. From here, the value will go here. Okay. This value you can forward here. So tell me, is add reading the wrong value? Add instruction, is it reading the wrong value? Yes, it is reading the wrong value, but it is calculating on the right value. Yes or no? It is reading the wrong value. It is reading the wrong value. Okay, so you can notice that this add instruction, this add reading wrong value, wrong R1. But what this is doing? This is fixing R1, right? Yes or no? Rectifying the mistake. This is fixing R1. So you are reading the wrong value, but you are calculating on the correct value. The calculation will happen on the correct value. There is no problem. This calculation will happen on the correct value. That's it. So in this case, what is the tick mark? We are using, okay. Oh, one more thing. So are we using both of them? We are using forwarding also, and we are using stall also. Both of them we are using, right? We are using forwarding also. We are using stall also. Both of them we are using. If we don't use forwarding, then there will be two stalls. Do you agree? If we don't use this forwarding, then there will be two stalls. You will need two stalls. But now we are only having one stall. So there is only, you can notice there is only one stall. This is your chapter. One stall only. So you are using forwarding also, you are using stall also. This is your question. This is your chapter. Every solution we have seen the hardware solution. You can read these notes. Okay. These notes you can read from the Hamacher. Whatever we have seen, that is already written here. This is the screenshot from the Carl Hamacher book. Carl Hamacher book. Very, very nice book. Another is software solution. We have seen this. You can notice this. We have seen, you can read it. Okay. You can read this. We have already seen NOP insertion that we have seen. Okay. Let's move on. Then another is operand forwarding. That also we have seen. This operand forwarding, is this hardware solution or software solution? This operand forwarding, is this hardware or software solution? And you are making connections, right? Some connections you are making. So this is hardware. Do you agree? Some connections you are making, right? You are making connections from buffer to the execution stage. Some connections you are making some wires you are adding. Okay, some data path you are creating. So this is a hardware solution. Let's move on. This was your forwarding path, right? From the execution stage buffer to the execution stage, from execution stage to execution stage. That's it. This is your chapter. Everything we have seen, let me promise you that everything we have seen, you can solve each and every gate question now. Okay. So before now we will solve the gate questions, each and every gate question. I have taken every gate question on the data hazards. Okay. We will solve all of them. Now tell me, did you understand so far? If there is any doubt, okay, small doubt, big doubt, if there is any doubt, now in the gate questions, it will clear. But some idea, did you understand that whatever I told you, did you understand the idea, the I can say the core, the logically, are you getting the feel of the pipeline? This pipeline is not a monstrous concept. Okay, it is not a terrible concept. It is not a terrifying concept. This is a very simple concept. Okay, if you understand this logically, just understand this logically, and this is a very, very, very simple concept. So what we are going to do now, the gate questions we are going to solve. Let's start with this question. Can you try this? Let's try this one. So this is gate 2007 question. There is a pipeline processor with the following 4 stages. There are 4 stages. You are fetching the instruction, you are decoding the instruction, and you are fetching the registers. You are reading the registers. KS is asking, forwarding from execution is only possibility. No. See, forwarding, for example, we have already seen this forwarding is possible. Either you can have forwarding, like either you can have this forwarding. In the question, actually, it will be given which type of forwarding you have. Either you can have execution stage to execution stage forwarding. Okay. Either you can have execution stage to execution stage forwarding. It simply means that you are in the execution stage, you can send the data to next execution stage. Okay. How the data path will look like? How the data path will look like? Let me tell you the data path. The data path will look like this. This is your execution stage. This is your execution buffer. This is your MA stage. Okay. So the data path will look like this. This is the data path that will look like. Okay. Okay. This is your forwarding. This is your execution stage to execution stage forwarding. Another forwarding that we have seen, what is that? MA stage to execution stage forwarding. Another forwarding that we have seen is MA stage to execution stage forwarding. This forwarding we have seen. Okay. So in this forwarding, what happens? In this forwarding, what is going to happen? What is the data path? In this forwarding, the data path is very simple, like this. This is the data path. And there is one thing, that is, there is complete forwarding, full forwarding. Okay, full forwarding. What this means? Sometimes if the information is not given to you, which type of forwarding we are using by default. Okay, if they do not mention in the question, they do not mention from where to where forwarding we are using. Tell me one thing. For every type of forwarding, we need to change the hardware. Do you agree? Like forwarding, whatever forwarding we create from execution stage to execution stage, if I want to create, see, if I want to create from execution stage to execution stage, I need to change the hardware. This connection I need to make. If I want this forwarding from MA to EX, then I need to change the hardware. I need to make this connection. You tell me, if I give you complete full forwarding, what it means? If I give you full forwarding, what it means? It means very simple. Just all the connections are available to you. Okay. If you have the value here, like whatever stage is this, I don't care what this stage is. If the value is here, like this is your stage SI. Okay. And this is your stage as J. So you can do this forwarding. Okay. Is this clear? This is called full forwarding. Full forwarding means you can forward from anywhere to anywhere, but you cannot time travel. Are forwarding is not same as time travel, right? Yes or no? Did you notice? Forwarding is not the same as time travel. We are not doing time travel. Forwarding simply means that if the value is already available somewhere, you can send it to where it is needed. Okay, so full forwarding, what it means? It means that if value available somewhere, already, then forward it. If it is already available somewhere, then forward it. Forward or bypass it to the place where it is needed. This is your full forwarding. Clear? So shall we start this question, this gate question? The pipeline is given to you. There are 4 stages. In the first stage, you fetch the instruction. In the second stage, you decode the instruction and you read the registers. Okay, you read the registers, then you execute and then you write back. These are the stages that are given to you. They are taking 1 clock cycle for each instruction. Okay, these stages, IF, ID, WB, these stages are taking 1 clock cycle to complete each instruction, each operation. The number of clock cycles for EX stage depends on the instruction. Add and subtract instruction, they are taking 1 cycle, and multiplication instruction is taking 3 cycle. In the execution stage, operand forwarding is used. So from where to where it is used? Operand forwarding is given to you. Tell me from where to where it is given. In the question, operand forwarding is used from where to where? From anywhere to anywhere. Okay. जहां जरूरत पड़े वहीं पे लगा लो. Okay, whatever you need, just use it. It is the full forwarding. Basically, in the question, full forwarding is given to you. Because the question is not mentioning from where to where. The question is simply saying that full forwarding is given to you. Okay, operand forwarding you can use. Now, what is the number of clock cycles taken to complete the following sequence of instructions? These instructions are given to you. How many clock cycles you need? Remember, the forwarding is given. Okay, let's solve it. So this is actually very easy question. Let's solve it. So actually, let me tell you one thing. What is the best way to solve? Now, I will change the diagram. So far, for understanding purpose, I was creating the diagram where I was writing cycles here. Okay. And then instruction here. This type of diagram you can create. Either you can create this type of diagram. See cycles here. Right? Do you remember this type of diagram I was creating so far? So far, I was creating this type of diagram. But actually, from my experience, this diagram is also fine. You can use this also. But from my experience, I like this diagram. Okay. I like the cycles. On the top, you write the cycles. It's like this. But here you write the stages. This is the diagram I personally like. All the pipeline question, each and every pipeline question I solve using this diagram. What diagram? In this diagram, and you can also use it. You can also use it. In this diagram, what I do, I just write the stages. I don't write the instructions. I write the stages. That instruction fetch stage, instruction decode stage, execution stage, and WB stage. So this is the diagram I create. I personally create this diagram to solve any gate question, any pipeline question. I always solve using this diagram. Just to explain you the concepts, I created the other type of diagram, but this is the diagram you can use. Okay, this is actually more, and in this diagram, what I do, these are the cycles. These are the cycles, like cycle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so on. Okay, and so on. Now let's see this. So the question, so either you can also use it, but this is just my suggestion that, like, the better, either you can use it, there is no problem, you can use it, you can write, like, you can write instruction here, then you can write instruction fetch, instruction decode, you can create this type of diagram. That is also possibility, that is also fine, but I prefer the next one. Okay, but I prefer the next one. So that is the reason I will be solving the question on this beautiful looking grid, this grid that you can see. Okay, so anyway, let me solve it. So for the first instruction, there is no problem. For the first instruction, do we have any dependency from anywhere else? Is there any dependency for the first instruction? So there is no problem, you can execute this. The add instruction is taking only one cycle in every stage. Remember, the question is saying that in every stage, this add instruction is taking only one cycle. So what will happen? This add instruction will go here, this add instruction will go here, then it will go here, then it will go here, and that's it. This is your add instruction. This is the add instruction. Then what will happen? Then let's see multiplication instruction. How many cycles it is taking in different stages? This multiplication instruction, it is taking one cycle in all the stages except execution stage. In the execution stage, it is taking 3 cycles. Okay, so this multiplication instruction, this I2, this is your multiplication instruction. It will go to instruction decode. Is there any dependency? Is there any dependency with I1? With I1, is there any dependency? Yes, there is dependency, right? Is there any dependency? Yes, there is dependency. We have dependency. Correct. So multiplication needs the value of R2. Where this value of R2 is available? This multiplication needs the value of R2, the correct value of R2. Okay, so where this value will be? This value will be available here. Here the value of R2 is available, right? Here the value of R2 available. Here R2 correct value. So what you can do? From where are you forwarding to where? Tell me where, from where you will forward where? From where you will forward where? From execution to execution you will forward. Very simple. That's it, right? So this diagram is actually more beautiful, that you are sending from execution to execution. This grid diagram is giving you more that you are sending from execution to execution, right? Yes or no? I don't like. Are you getting that intuition that what is happening here? From execution to execution, you are giving. You are passing the value from execution to execution. Okay, because you know that here in the execution buffer, the value is available. This is your execution. This is your execution buffer. Here the value is available. Okay, here the value of R2 is available. This R2 value is available. You will send it to execution stage directly. So this I2 can go here. Now in the next, can I2 go here? Can the multiplication go here? Can the multiplication go here? No, because the question is saying that multiplication needs 3 cycles in the execution stage. Multiplication needs 3 cycles in the execution stage. In the execution stage, it needs 3 cycles. Then it needs 3 cycles. Then it will go here and then out. Then out. Okay. So when this multiplication is in the ID stage, then can we fetch the next instruction? When the multiplication it is in the ID stage, this I2 is in the ID stage, can we fetch the next instruction? Of course. Of course, you can fetch the next instruction, sub instruction. Is there any dependency? Do we have any dependency? Yes, there is this dependency. There is this dependency. Okay. This R4, this dependency we have. So you can notice this I3 can go here. Then this I3 can go to the decode stage. But can the I3 go to execute stage? Tell me. Is execution stage free? Is execution stage free? No, you can notice the execution stage is not free. So you cannot go. So here the stall will happen. Stall will happen. These I'm using for stall. Stall is happening. Okay. So you have to wait. Basically, this I3 has to wait in the decode stage. It has to wait. It needs the value where the value is available. It needs the value of R4 where the value of R4 is available. The value of R4 when it is available here. Very good. Okay. Very good. Very good. It is available here. This value is available here. So here you can notice. So from here you can pass it, right? From execution to execution, you can pass it. From execution to execution, you can pass it. That's it. Then this I3 can go here. Then it is pass. How many cycles? This is your answer. How many cycles you need? 8 cycles. 8 cycles to complete the. Tell me, did you enjoy? Like with clear understanding, did you enjoy that the forwarding is happening from what is the forwarding data path? Okay. Did you understand the forwarding data path, the data path, how the hardware is changing, how we are modifying the hardware? Okay. Because ultimately everything needs to be done on the hardware. So how the hardware we are changing, from where the forwarding is happen to where, from execution stage you are passing to the execution stage, you are playing the game, pass. Okay, so you are passing from execution stage to execution stage. Did you notice that in this explanation everything is very crystal clear? Like what is happening, everything is very crystal clear, right? Okay, that is the reason this diagram is my favorite. This diagram gives you more intuition. Okay, in this diagram you are getting more intuition. One more thing, in this diagram you can never make this mistake. Which mistake? In this diagram you can never make this mistake that I3 will go, because it is stopping you, because I2 is stopping you. Like this I3 we go here, because this will stop you. Okay, so anyway, so this is the complete explanation. The answer will be 8 cycle. For this question the answer is 8 cycle. I hope you understood. Okay, now let's move on. Let's see this question. Tell me the answer. This is gate overflow test series. This is not from Go Class test series. This is from gate overflow test series. Okay. Mock test 6. Okay. Before we solve this, did you attempt, like, do you have any plan to attempt this? Have you already attempted gate overflow mock test 6, mock 6, gate overflow mock 6? Have you already attempted? If you have already attempted, see, if you have already attempted, then I can solve the, then you can see the solution of this question. Okay. If you did not attempt and you want to attempt, because only few days are remaining in the gate exam. In the gate exam, I think only 7 or 8 days are remaining. So that is the reason I am asking that. I am telling you, if you want to attempt this mock test, gate overflow mock test 6, if you want to attempt, then please don't see the solution that I am giving you. Okay, this solution don't see. Okay, you can mute or you can do something if you want to attempt this mock test. If you have already attempted, then very good, then let me give you the solution. So this is a beautiful question, very beautiful question from the gate overflow test series. Why this is beautiful, you will see. So this is from gate overflow test series mock test 6, question number 38. Let's see this. The details are given to you. Consider 5-stage pipeline: the instruction fetch, instruction decode and register read, execute, memory and write back. And the information is given to you. All register reads take place in the second phase of the clock cycle. All register writes occur in the first phase of the clock cycle, and there is no operand forwarding. What it means? What this means? Register reads are happening in the second phase of the clock cycle. Register writes are happening in the first phase of the clock cycle. What this means? This is your split phase. This is what some people call a split phase, right? Like if this is your cycle, the question is very beautifully framed. every information is given to you, right? In this question, every information that you need to solve this question is given to you. The question is very simple, that this is your cycle. Then here you are writing and here you are reading. This is this, some people call it split phase. Some people call it split phase. Okay. But there is no operand forwarding. We cannot use any operand forwarding. Consider the execution of the following instruction sequence. This instruction sequence is given to you. Now, first, before we solve this question, actually the question is asking for hazards. Actually, the question is asking for hazards. But what one variation is possible? One variation, what is that? That is dependency. So before we solve this actual question, let's find out the dependencies. So tell me, for dependency, do you care about the pipeline? For dependency, do you care about the pipeline? How many dependencies are there? RAW dependency, WAW dependency, WAR dependency. How many RAW dependency? You tell me, in this I3, what are we reading? In this I3, what are we reading? Which register we are reading in this I3? In this instruction I3, which register we are reading? Remember, we are reading I1, R1 also. We are reading R3 also. We are not writing into R3. In this instruction, we are not writing. We are not writing into R3. We are writing into the memory. Is this clear? This R3 has something. In that memory location, this R3 has address. In that memory location, we are writing. We are not changing the R3. So remember this point. Okay. Now you tell me, how many RAW dependency? So the number of RAW dependency, you can notice this. This is RAW dependency. This is RAW dependency. This is RAW dependency. Clearly 3 dependencies plus. This is RAW dependency. One more plus. This is RAW dependency plus one more. That's it. That's it. Okay. So your final answer will be what? How many RAW dependencies? 5. You have total 5 RAW dependency. How many WAW dependency in this question? What is the number of WAW dependency? Right after right. None of them. 0. Okay. Very good. 0. How many WAR dependency? Just go in the reverse direction. Go in the reverse direction. R2, R2, R2. Yes, this is your WAR dependency, R2. Then this is your WAR dependency, R2. Plus what else? What else? R3. There is another. Okay, so the answer will be 3. How many WAR? 3. How many RAW dependency? 5. How many WAW dependency? 0. Understood? This is the question related to dependency. If you want to find out dependency, then you don't have to worry about the pipeline. These pipeline details do not matter if you are finding the dependency. But what the beautiful, this question, why this question is beautiful, I will tell you, because the question is asking for hazards and the pipeline details are given to you. So tell me, in this pipeline, this is your classical RISC pipeline. This is your classical 5-stage pipeline. This is an in order pipeline. You already know. Okay. This is the pipeline we are comfortable with. This is the pipeline we have already seen many times. So tell me, in this pipeline, how many WAR hazards will be there? How many WAR hazards? There will be 0 hazard. How many WAW hazards? There will be 0 hazard. So all of them, they are basically 0. You have no WAR hazard. You have no WAW hazard. These are 0. Only we have to find the RAW hazard. Tell me one more thing. We need to find the RAW hazard. So for that, what we need? What we will do? When you have RAW hazard, when you are finding, then what you will do? Very simple. Just do the normal execution. Okay. So just do the normal execution. C1, then 2, then 3, then 4, then 5, 6, 7, 8, 9, and so on. Okay. Just do the normal execution. This is your instruction I1, I2, I3, I4. It will go to instruction fetch. Then it will go to decode. Then it will go to execution. Then it will go to MA. Then it will go to write back. Okay. So let me quickly write it. You tell me, please solve it. How many hazards? How many RAW hazards? This is your question on your screen. Try this. Take 1 minute. Hi everyone. So what is the answer? Please tell me. How many RAW hazards are there? See, the question is very simple. The everything is already given to you. There is no operand forwarding. Everything is given to you. All you have to do, just do instruction fetch, decode, execution, MAWB, instruction fetch, decode, execution, MAWB. Now you can notice where are the dependencies. Just look at the dependencies. Remember, some dependencies will be hazard. Some dependencies, some RAW dependencies can become RAW hazards. What about this dependency? Will it become hazard? Will this dependency become hazard? Yes, because split phase is already given to you. So there is no operand forwarding. We have no operand forwarding. So where the available value? Because remember, there is no operand forwarding. The question is saying there is no operand forwarding. So what it means, here the R1 value will be available. Here the R1 correct value will be available. But where are you reading? But where I2 is reading? Where I2 is reading? I2 is reading here. So this is a time travel or not? Tell me. R1, the correct value, because there is no operand forwarding. The question is saying there is no operand forwarding. There is a split phase. There is a split phase. So that is the reason here R1 will be available. But I2 is reading R1. This I2, this instruction, it is reading R1 in this ID stage. This is time travel. So this is your hazard. So you got your first hazard you got. So this is, I can say this, these are your row hazards. Row hazards, these are between instruction or between registers. Should I write between register or between instruction? Between instructions. So remember I1, I2, this is a row hazard. This is the first hazard you got. Okay, where is the second hazard? What about this one? What about the this one? What about this one? Tell me, what about this one? I1, I3. What about the I1, I3? See, here the correct value will be available. Here the correct value will be available. But the I3 is reading here. Again, this is a hazard. So next hazard you got, that is I1, I3. This I1, I3 hazard you got. Okay, where is the next hazard? Is this, what about this one? Look at this I1, I4. I1, I4. Look at this I1, I4. Is this hazard? This I1, I4, is this hazard? No, this is not a hazard. There is no problem here, right? There is no problem here. This is perfect. This is a perfect. There is no problem. You have no problem. So this is not a hazard because there is no time traveling here. Okay. So there is no, this is not a hazard. So you can see these are the two hazards. Now, what about the next dependency? Look at the next dependency. This R3, R3. What about this R3, R3? This R3, R3 means I2, I3. This I2, where the value will be available? The value will be available here, correct? Again, the same point, the value will be available here. Here, the value R3 will be available. The correct value R3 will be available here. But this I3 is reading here. So this is a time traveling. Similarly, what about this one? From R3 to R3. What about this one? I2, I4. So you can notice, so you can notice I2, I3, this is a hazard. What about I2, I4? Tell me, what about I2, I4? Yes, that is also a hazard. I2, I4, that is also a hazard. So you can notice this I2, I4, this is also hazard. So how many hazards? That's it. That's it. 1, 2, 3, 4. There are total 4 hazards. So your answer, your A value will be 4. The question is asking this. So the answer will be total 8. Simple question. This type of questions, if they come in the GATE exam, can you solve them? Can you solve all of them? If this type of questions come in the GATE exam, let's see one GATE question. The question is asking for dependencies. Pipeline details are given to you. Do they matter? Do they matter? The question is asking how many dependency in the sequence of instruction. In this sequence of instruction, how many dependencies? Okay, in this sequence of instruction, how many dependencies? The pipeline details, they are just to confuse. Those students who do not understand the correct concept, they will just get confused. That's it. But the pipeline details do not matter. You can remove them. Okay, so just look at the program. Okay, there is this, like, this is pure nonsense for this question because the question is asking for dependencies. So here the answer will be what? In the sequence of instruction. How many? First, let's check for the WAW. How many WAW hazards? Dependencies. WAW dependencies. How many WAW dependencies we have? So you can notice that these are the people that we are writing. So there is one from add to subtract. There is one from add to subtract. From add to subtract. So there is one here. Okay, from add to subtract. And there is another from multiplication to division. There is another from multiplication to division. So there are 2. So how many dependencies? There are 2. WAW dependency, that is 2. So this option is gone. This option is gone. 2 options are remaining. One of them you have to check. Just check one of them. Let's check RAW. RAW, let's check because 2 options are already gone. So let's check RAW dependencies. How many RAW dependencies? You can notice that this R5 you are using here. So this is one. I can say, for example, I can say I1, I2. This is there. Let's call it I1. Let's call it I2. Okay. What else? R5. See, is this dependency? Is this RAW? Is this RAW dependency? No, this is not RAW dependency because in between R5 you are writing. You are writing R5. So remember, this is not I1 to I4 is not RAW. Okay, so that is not RAW dependency. But you can notice I can say, so for R, let's see from R6 point of view. So there is dependency. So that is like I2 to I3, there is a dependency. Okay. From R6 point of view, is this dependency? Is this RAW? Is this RAW? No, this is not RAW because we are writing R6 in between. So again, you cannot, this is not. So remember this I2 to I5 is not. Okay, remember this I2 to I5, that is not. That is not. Okay, so finally, what else? Yes, this one. I3 to I4, I3 to I4. That is a dependency. Okay, and then finally, I4 to I5. So how many? Total 4. So your answer actually will be option C. Answer will be option C. But you can calculate WAR also. You can also calculate WAR dependency from the, just go in the reverse direction. So you can notice this is, there is, this one is there. Okay, so R6. So you can notice there is one, like I can say, from I3, I4, there is WAR dependency. What else? You can notice that I2, I3, this is also WAR dependency, I2, I3. What else? Okay, what else do we have? That's it. Only 2, right? So that is the reason your answer is 4 to 2. Very simple question. Okay, so these are some gate questions. Can I give them as a homework? Like these are simple questions which we have already done. Okay, so can I give? You can see, you can solve it. These are same type of questions we have already done. Many questions we have done. So let me give you this question as homework, where you can see the solution. You try this question, and if you don't understand, if you have any doubt, then you can see the solution on the Gate Overflow website. Okay. Similar, this question also we have done. Actually, this type of question also we have already done. So let me give you this also as a homework. Let me give you this also as a homework. These are performance-based questions. All these are simple questions. We have already done many of them. Okay, just try them. Just try them, homework. All the concepts you already know. Everything you already know. Yeah, this is a beautiful question. The question is asking for anti-dependency, and then will they create stall? Yeah. Okay. So tell me what, this is a simple question. Let's solve it immediately. This is GATE 2015 question. In this question, tell me the pipeline details are given to you. Are the pipeline details given to you? This is a GATE 2015 latest question, only few years ago. The pipeline details, are they given to you? Why they are not given? Debanjan, Sudeep, why the pipeline details are not given? Because the question is asking for dependency. There is no sense. There is no sense of pipeline details. The question is only asking for dependency. Consider the following code sequence having 5 instructions, I1 to I5. Each of these instructions have this format where this is the destination. Where this is the destination register. Okay, where this is the destination register. Now, these are the instructions that are given to you. These are the instructions. Okay, now the question is asking, which of the following 3 statements? There is anti-dependency means what? Anti-dependency means what? That is WAR dependency. That is your WAR dependency. Is there between I2, I5? Do we have WAR dependency between I2, I5? This is your I2. This is your I5. Do we have? The answer is no. The answer is no. Okay, very good. But we have WAW, right? Yes or no? If you notice I2, I5, then this I2, I5, they have WAW. They have WAW dependency. They do not have WAR dependency. Okay, but yes, they have WAW dependency. They do not have WAR dependency. What about WAR dependency, anti-dependency between I2, I4? This I2, I4. This is your I4. This is your I2. Yes, there is. Yes, there is. Okay, so there will be this. Very simple. Okay, now this is a nice question. Within an instruction pipeline, anti-dependency always creates one or more stall. Anti-dependency creates one more stall. The answer is no. Okay. Now this is not the correct. Sorry, this is not the complete analysis, because remember, many students, they think they don't really know. See, actually, these anti-dependency will never create stall. Yes or no? I told you that if your pipeline is this, I told you there are two type of pipeline. Actually, there are two type of pipelines. We have two type of pipelines in the Carl Hametzer book. This is given to you. I will. We have already seen this in the Carl Hametzer book. This is already given. There are two type of pipelines. One is simple pipeline that we study. One is simple in order, or I can say these are like simple pipelines. Simple pipelines. Another type of pipeline are called super-scalar pipeline. Super-scalar system. Another type of pipeline, these are super-scalar pipeline. Okay. So you already know that here there is no WAR hazard. Correct? We have no WAR hazard. Here you have WAR hazard. WAR hazard possible, but that is eliminated, right? That can be eliminated. That is eliminatable. I told you 100% eliminatable. Possible. So these are possible, but 100% eliminatable. Okay. Anyway, you can notice that this anti-dependency, it always creates one or more stall. No, it can actually, the answer is never, because the question is asking for actually, not never, because as I told you, in the super-scalar system, I can say never in order pipeline. Okay. I can say never in order pipeline. This is what I can say, that never in order basic pipeline, in a simple pipeline. Okay. Where you have one instruction, every instruction goes through all the stages. Every instruction goes through all the stages. You execute them one by one. You execute them one by one. Okay. So like this. So you can notice never in the in order pipeline. Very simple. This is your question. Okay. Now let's move on. Now let's see. So this question we will discuss in the marathon. I will take pipeline marathon. In that marathon, I will discuss, but you can solve it. Everything we have seen, the question is asking for data dependence. The question is asking for data hazard. The question is asking for everything that question is asking. You can solve it, right? You know what is data dependence. You know how to detect data hazard. You already know everything. So let me give you this as a homework, but I will solve all these homework questions. Every question that I'm giving you as a homework, I will solve them in the pipeline marathon. Okay. But you try them before that. At least try them. Okay. In the pipeline marathon, I will solve each and every question. So do not worry about it, but you try. Similarly, try this question also. Each type of question we have done. Each type of question. Try this also. Okay. Just last point I want to tell you. Do you remember what I was telling you? I was telling you that at the end, I will tell you about out of order execution. This last point, this last simple last point I will tell you. This is the last session, that WAW and WAR hazards. When are they possible? When are they possible? So let me tell you. Very simple point. Actually, there is a concept of super-scalar system. There is a concept. You can notice there is a concept, super-scalar operation. So let's see this super-scalar, what this is. Super-scalar system. Super-scalar system. What this system is like this, that in the instruction fetch, you can fetch many instructions simultaneously. In the instruction fetch, in the instruction decode, many instructions you can decode simultaneously, many instructions you can execute simultaneously, and so on. Basically, you have a lot of hardware you have. Okay. A lot of hardware you have basically. Okay. A lot of hardware you have. Many instructions simultaneously you can fetch. Many instructions simultaneously, like 4 instructions you are fetching simultaneously. In the same cycle, 4 instructions are decoding, 4 instructions are using ALU, and 4 instructions are using data memory, and so on. Okay. This type of system is called super-scalar system. Now, what happens in these systems? What happens in these systems is something interesting. See, in these systems, if you have this type of let me give you, if your instruction I1 is like this, that R1, okay, you are writing R1, then something maybe R2 plus R3. See, just understand this very simple concept. Okay. So case first you understand this. After that, I will tell you, don't worry. First you focus on this. Now let's I2. In the I2, let's assume you are reading R1 and then something you are doing R5. Okay. In instruction R3, let's assume you are writing into R1, R6 plus R7. Now see, something interesting will happen. In our normal pipeline, this can never create any problem. This can never create any problem, right? This WAW dependency never creates any problem, any stall in order pipeline, in our simple pipelines, in our simple in order pipelines. In order means just come in order, one by one. Okay, come one by one. Come one by one. Okay, very simple. So this can never create. But now something interesting will happen, that in the super-scalar system, these can create. See, what can happen? Let's assume 3 instructions can come in the instruction fetch at the same time. You are fetching the 3 instructions. Okay, you are fetching them together. So this is your instruction fetch. In the instruction fetch, let's assume you are fetching this also. You are fetching I2 also. Let's assume you are fetching I3 also. You are fetching them together, all of them. Now they are decoding. Okay, in the decode stage. Now they are in the decode stage. In the decode stage, I1 you are decoding I2 also, you are decoding I3 also. Okay. Tell me one thing. When you are decoding something interesting, you tell me what value of where actually what should happen? This value should read. But where this value will be available? In the decode stage, will this calculation happen? In the decode stage, will this calculation happen? This calculation will not happen. You can notice this I1, it will calculate this value in the execution stage, correct? Yes or no? So you are reading the wrong value, right? Yes or no? Is this clear? This I2 reads wrong value. This I2 reads wrong value of R1. Is this clear? Please tell me a simple point. Because this calculation will happen in the execution stage. This calculation is going to happen in the execution stage. But you are reading this R1, so I2 is reading the wrong value of R1. Okay. So what should you do? You should stall. So definitely you cannot allow that. You cannot allow reading the wrong value. Reading wrong value is not allowed. So what you will do? You will stall. So this I2 should remain. This I2 should remain. But who will pass? See, this I2 should remain. This I2 should remain. So it should happen that this I2 should remain, but I1 and I3 will go to execution stage. Correct? Yes or no? I1 and I3 will go to the execution stage and I2 will wait. This is waiting. Is this clear? Please tell me. Let me know. I2 should wait from in this decode stage because I2 is reading the wrong value. I2 is reading the wrong value, so I2 will wait. So I2 waits in ID stage. Okay. So here what will happen? This I1, I3 will go to the execute stage. Now can you notice? Now can you notice that the final value of R5, who will write? Now can you notice the final value of R5, who will write? Tell me. The final value of R5, here R5 of, here you should have R5 of I3, but you will get R5 of R2 because first it will write, then it will come and it will overwrite. So you can notice that that is wrong. Yes or no? That is something which is wrong. Yes or no? So did you notice for the first time, did you notice that WAW also can create problem? Now is everything clear? In your mind, is everything clear that when RAW will create problem, When WAW will create problem, when WAR will create problem. WAW, they can never create problem in your simple pipeline where instructions are going one by one, where instructions are going one by one after one. Okay, one after one. Then WAR can never create any problem. But in this system, super-scalar system, in these systems where you have a lot of instructions, a lot of instructions are executing simultaneously in the same stage. Okay, many instructions you are fetching in the same cycle, many instructions are decoding in the same cycle, many instructions are executing in the same cycle. So in this type of super-scalar system, WAW also can create problem, WAR also can create problem. And you can notice RAW is creating problem. RAW is already creating problem. So you can notice this RAW is creating problem. This is creating problem. Understood? This is simple point I wanted to tell you. I just wanted to tell you that actually what is happening here. This is called out of order execution. This is out of order execution, right? Out of order execution. You are executing them out of order. It means that in the super-scalar system, what happens? In the super-scalar system, we fetch them in this order. In this system, what happens? In this system, this is your code. Your code is I1, then I2, then I3. This is your code. Remember, we fetch them in this order. The super-scalar system will fetch in the code order. Will fetch instructions in the code order. But may execute them in out of order. But may execute them out of order. This is called out of order. Actually, many students have misconception in out of order. What they think? They think, this is what I have seen. Many students have this misconception that what they think that these instructions will these instructions will shuffle. No, these instructions are not shuffling. These instructions are not shuffling. We are fetching instructions in the correct order. We will fetch them in this order. Like these three will come, then these three will come. So we will fetch them in this order, but they are executing out of order. For example, you can notice that these three instructions you are fetching in the right order. I1, I2, I3. You are fetching them in the correct order, but they are executing out of order. First I3 is executing, then I2 is executing. So they are executing out of order. So this is what happens in the super-scalar system. So you can notice that when out of order execution happens, when out of order execution, this is in simple words, this is called triplo. In many standard resources, you will find triplo. Okay, triple O. When out of order execution happens, then what are possible? Tell me. Happens. Then when this out of order execution happens, then WAW, WAR, RAW, hazards, all of them are possible. Okay, all of them are possible. But now something interesting, that these can be eliminated completely. These can be eliminated completely. Eliminated completely. Completely means 100%. These can be eliminated completely. Okay, this is real problem. This is always a real problem. This is always, remember, this is always the real problem. So how can they be eliminated completely? Let me tell you, this WAW. Okay, how can you eliminate WAW, WAR 100%? Eliminate them 100%. How can you do that? Very simple. Very simple. Just tell me, why are they, just think about it. Why are they created? They are created because you are writing into R1, something you are writing into R1, and then again you are writing into R1. Don't write into R1. Yes or no? This is the problem, right? that you are writing into the same register is the problem. Writing again in the same register is the problem. Agree? Do you agree with me that you are writing again in the same register? That is the problem. Writing again in the same register, that is the problem. So don't write. So what is the solution then? What is the solution? Don't write in the same register. Okay. So never write in same register twice. Don't write in the same register twice. So for example, if you want to do this, in R1 you want to write something, then in R1 again you want to write something, just don't write, just change, just do the renaming. Just do the renaming. What you do? Just do the renaming in R1. Here you don't write into R1, just write into R11. Now there is no problem. Did you notice this we do in the SSA? Okay. SSA, do you remember SSA in compiler design? Do you remember? This is what we do in SSA in compiler design. Single static assignment in compiler design. That is the same concept. That is the same concept. Renaming, renaming, and that is similar. That is similar to SSA concept. Okay, and these hazards will be gone entirely. So this is your renaming concept. So what is your renaming? This is a renaming is a mechanism. This renaming is a mechanism to eliminate WAW, WAR hazard entirely 100% from any pipeline. From any pipeline. Okay. All you have to do, just like whenever you are writing, all these must be different. All these people must be different. Okay. Just like, okay, always write into different registers. All these are different registers. That's it. That's it. If you are, okay, can you prove it? That if you are writing to different registers, WAW is gone, right? Whether you do reordering out of order, in order, whatever you do, that is gone. Do you agree? If you write into different registers, like different registers are there, here R1, here R2, here R10, here R50, then whether you do in order execution or you do out of order execution or you do any execution, whatever execution you do, WAW gone. WAW gone. Similarly, WAR gone. Okay, why WAR gone? Why WAR gone? WAR is also gone because we assume that initially, like basically we always, like for example, even if you are doing this, like this R1 plus R1 also, if you are doing, then always write it into something new. Always write into something new. Always write into something new. Okay. So this is the point. Always write into something new. Always write into something new. So if you do like this, then RAW is also gone. There is no RAW. Sorry, there is no WAR. So you can notice there is no WAR. There is no WAW dependent hazards. These hazards are gone. Using the renaming technique. Okay, that's it. This is your chapter. Clear? Is this clear? So let's we will meet again at 10 p.m. Okay. The final topic that I will teach is control hazards. Okay, let's finish it. This is small actually. This is not very complicated. This is small topic, control hazard. Okay. So we will meet at 10 p.m. Yes, branch prediction, those concepts. Okay. So we will meet at 10 p.m. Okay. Thank you. Yes. Tell me, what is your doubt? KS? What is the doubt? Can you send? Yes, one final lecture, that is control hazards. This will be one final lecture. KS is giving some code is given to you, and KS is asking, sir, in this case, is there WAR dependency between 1,4 between 1,4 WAR dependency R3? Okay, no, so there is no WAR dependency there. Okay, in that there is no WAR dependency, because in the I2, in the instruction I2, you are writing into R3. Okay, so you can watch the second lecture. Yes, the second lecture you can watch. So because in the instruction I2, you are writing into R3. Okay, so that is the reason. So there is no WAR dependency between instruction 1 and instruction 4. Okay, this we have also seen in the second lecture. Okay, so this is the final session, control hazard session. We will have this session at 10 p.m. Okay, so you can have your dinner. We will meet after 1 hour. Okay, thank you everyone. So I hope you understood this data hazard, data dependency, how to detect hazard, how many data hazard, how many row hazard, WAW hazard, RAW hazard, renaming. Okay, out of order, in order, everything, each and every concept. Is it clear? Okay, very good. So thank you. And the final topic that is remaining, that is control hazards, control dependency. Okay.